Good morning, everyone. Today, in discrete mathematical structure, we will have the fundamental principles of counting. So, let us see what do you mean by fundamental principles of counting. So, first, we will try to understand what do you mean by counting. Everyone knows that we know how to count. That is one, two, three, four, like this. We are going to count the numbers, isn't it? Something. Suppose if there is a basket here, and then say there are few fruits like this. So now you can count. This is fruit number one, this is two, this is three, this is four, five, six, seven, and eight. So in total, this basket has eight fruits. This is what you are counting, how many fruits are there in this basket. Okay, that is what the meaning of counting. Okay, what do you mean by counting? So there will be some objects, collection of objects. So here there are objects. Objects are there where you are going to count how many objects are present. So that is what it is going to be referred as counting. Okay. It is also called as enumeration. Okay. Let us see what do you mean by counting. Counting refers to what? Quantity. It refers to quantity. It is an action of finding numbers of elements of finite set of objects. That is, I cannot say that this there is a basket. I can say there are 10 fruits, or else I can say there are 100 fruits. I can say 1,000 fruits, but I cannot say infinite fruits. Means there is no end. Okay. If there is no end, I am unable to calculate the number. That's why there has to be finite set. Means some fixed numbers has to be there. 10, 12, 40 fruits, 50 fruits. Like this, some fixed number of objects should be present. Only then we can able to count the quantity. Means we can uh, tell how many number of objects it is having. So that is what counting refers to. The purpose of counting is to assign a numeric value to a group of objects. That is what just now I have told you people. That is, if there is a basket of fruits, so I can assign a number. That is how many fruits are there here? There are six fruits as per this example. So numeric value I can able to assign to a group of objects. Now, already I have told you that counting is also called as enumeration. In counting, there are two major rules. That is, one is rule of sum and other one is rule of product. Now let us try to understand what does this rules say. That is rule of sum and rule of product. Okay. So the first one we will take rule of sum. So what do you mean by rule of sum here? Now, say for an example, in one cupboard or else one box, I'm having three balls. That is red, blue, green. In another box, say I'm having three toys. Say one I'm having bus, another one I'm having train, and say I'm having car, and say I'm having cycle. There are four toys and 3 balls. Okay. Is one small kid. To this kid, I want to give any one. Okay. Either one ball or else one toy. Okay. I will give option to this kid. He can choose now. Kid can choose a ball or else a toy. Only one thing he has to choose. Okay. So what are the possibilities now? He may choose ball, that too red ball. He can choose red ball. Or else he can choose blue ball. This is red or blue or green. Okay. He can choose red ball or else blue ball or else green ball. Or else what he can choose? He can choose bus or else train or else car or else cycle. Okay. He can choose any one of these. So in total, how many possibilities are there for this kid to choose? 1, 2, 3, 4, 5, 6, and 7. So what we can say here, there are 3 balls and there are 4 toys. So total, how many? There are 7 ways of choosing this. Now, when you see this choosing, it is not simultaneous, means it is different. Balls choosing is separate and then toys choosing it is separate. It is not dependent. Means one ball he has to take, one toy he has to take. No, it is not like that. Any one he has to choose. That's why we have to add these two. Okay. This is what called as rule of sum. Let us see the rule and try to understand. Okay. Say this is task 1. Task 1 is what? To choose ball. Okay. Now task 2 is to choose the toy. Any one toy. Or now in task 1, in task 1, how many options are there? There are 3 options because there are 3 balls. In task 2, there are how many options? There are 4 options. Okay. Now both I am not doing at a time. We are going to add these two things. Okay. So now let us see the rule. The rule says if the task T1, if the task T1 can be performed in m different ways. M different ways. For example, 3 balls. Okay. And the task T2 can be performed in n different ways. N, that is number of toys. And if these two tasks cannot be performed simultaneously, means both I'm not taking, only one I have to choose, either ball or else toy. Then one of the two tasks, that is T1 or T2, any one, can be performed in m plus n ways. Now, let us take example and try to understand. So here there is an example. College library has 40 textbooks on visual programming and 50 textbooks on mathematics. In how many ways a student can select any one book? He has to choose only one book. Now, try to understand. Any one I have to choose. So, visual programming, how many books are there? 40 books are there. I will call this as M. Okay, according to our statement. Okay. How many books are there? 40 books are there. Now, maths, how many books are there in that library? That is 50 are there. I have to choose any one. Okay, means I can choose any one book from visual programming, or else any one book from mathematics. Okay, so totally how many ways are there? So there are 5 plus 4, 9. There are 90 ways of selecting. Let us see how the solution is. Visual programming textbooks, M is equal to 40. Mathematics textbooks, N is equal to 50. Total number of ways to select the books will be equal to how much? M plus N. Just now you have seen the formula. So it will be 40 plus 50, that is 90 ways. Okay. We'll take another example. So, example number 2. Suppose a university representative is to be chosen, either from 200 teaching or 300 non-teaching employees. Then find out in how many ways a representative can be chosen. Okay. What is the meaning? First, try to understand the problem. University representative is to be chosen, means only one person. From how many? 200 teaching staff. How many are there? There are 200 staff. Non-teaching, there are 300 staff. Okay, then find out in how many ways a representative can be chosen. Okay, so how many then? So total 500. Always do remember, if or term is there, then we are going to add. If and is there, means both we have to do. Both we have to do. In that case, we have to multiply. Do remember this concept. Okay. But before you decide this, first read out the statement given, then you come to conclusion. Right? So let us see the solution. Number of teaching employees, we will consider it as M. So it will be 200. Number of non-teaching employees, N is equal to 300. So total number of ways to choose an employee will be M plus N. That is 200 plus 300. Totally how many? 500 ways. Okay. Now let us take another example. What is the number of ways that a student can select a project from information science or computer science or engineering? There are 20 projects in information science, 35 projects in computer science, whereas there are 15 projects in engineering. Information science, we are having 20 projects. Computer science, we are having 35 projects. And engineering, we are having 15 projects. Okay. As only one project has to be chosen. A project has to be chosen. That is, or term is there. We have to make use of addition. Okay. Now, see here. Information science, we are having how many projects? 20 projects. Then computer science, we are having 35 projects. Then engineering, we are having 15 projects. Correct? Now, this time we are having 3 terms. But in the formula, rule of sum, we have seen that is M plus N. Correct? If more number of tasks are there, this is task T1 and this was task T2. For example, there are other tasks. Then in that case, we should go on adding. For example, task 3 is also there. then we will add one more term. If task 4 is there, then we will add one more term like this, MNPS, whatever it is. We will go on adding. Okay. Now, let us see the solution. Number of projects in information science. M is equal to 20. M is equal to 20. Number of projects in computer science. We are having 35 projects. That we will call it as N. There is one more. That is number of projects in engineering. That is P. P is equal to how much? 15. So now total number of ways of selecting a project will be equal to M plus N plus P. That is 20 plus 35 plus 15. That is totally how many ways? 70 ways. Okay. Hope so you have understood the concept, how to use rule of sum. See you all in my next video, and thank you for watching.